welcome to Ars Mea. And let's talk about some rocks for a minute. These rocks, these two buckets, and then this very large rock here are the ore that I removed from my previous trip over the weekend. So this is, between these two buckets, I have 118 pounds of ore, and this particular boulder is 62 pounds, so I've got 180 pounds total. And what I want to show you is some of the variation. Now what we're looking at here, this is a quartz rock with galena in it. Now that galena is what we're after. It should be basically mostly lead, and it'll have a significant amount of silver in it. But the rock that I got varies greatly. See, this one has very little visible galena. I believe there's some in there. Whereas this rock appears to be almost pure galena. It's a very shiny, dark gray material. So I have to break up all of this quartz in order to get the galena out. And that's what I'll be doing today. And the way I'm going to be doing that is through the properties of the quartz. I want to show you this is not actually part of my ore, but this is a quartz crystal. And one of the things to notice is this has a very regular shape to it, and it's also somewhat irregularly shaped, but all quartz crystals share this shape when they're below a certain temperature, which is 1063 degrees. So when you're looking at a chunk of just white quartz like this, you're actually looking at thousands upon thousands of very small crystals that have that shape. So they're all packed together, and this is another excellent example of how a bunch of crystals are packed in random kind of directions. Once again, this isn't ore, but these are just large crystals that I happen to have. If you can imagine this ore as having all those crystals, but very tiny and interlocked. Once they're heated beyond 1063 degrees, which I'm just going to start calling 1100 degrees, because it's much simpler to say, they change shape and become a much more regular cross-section. So one side shrinks and one side expands, and that pushes and pulls on all the crystals around it. And each crystal will be doing this, and basically what you get is micro-cracking down between all the crystals. So that will cause the quartz to be easier to break up. To really compound that, I have a 55-gallon drum of water over here. And I've got a garden hose running into it. I'll be keeping it full as we go, but once these rocks are up to temperature, which I will be checking with an infrared thermometer, then I'm going to pick them up, pitch them into the water, and not only will they have the micro cracks, but they will have the heat stress cracking as well, which will make them much easier for me to break up and get the galena out. I still have to do more processing beyond that, but I'm trying to make it as easy as I can for myself, because I really don't have $3,000 or $4,000 to buy a rock crusher. So I'll be doing this by hand, so easier is better. That said, one I'm going to start is just heating up a rock. When it's hot enough, I'll pitch it in, and while I'm working on that heating, I'm going to start breaking this up, because it's literally just too large to go in there. This has large crystals, some of this has small crystals, some of this is mostly galena crystal. We're just going to see what we get. So I'm going to move this cart out of the way so you can kind of see the process, get everything lit up, and start heating some rocks. Our first victim. One thing I will say is the galena melts just a little bit higher than the temperature that we're aiming for. So it is possible it will melt out some galena. I'd rather not, but it's possible. And if that should happen, I've placed these rocks in pan down below in the hopes that it will catch any melt out. But beyond that, we'll just have to see what happens. So while that's doing, I'm going to start beating up this rock. Right there is a piece of that rock that I just beat up. You can actually see just large amounts of galena. You can see iron staining from where the iron pyrites, which is an iron sulfide, the same way that this galena is a lead sulfide. And the lead sulfide is what we're after because it should contain small quantities of silver. So we're going to get that out as lead and then separate the silver from it. $350 degrees or so. Hey, so it's me from the future, just a day or two. Just wanted to pop in real quick and let you know that this worked, but it worked slowly, and this is going to be a very long video. And it actually, I was having so much fun playing with my rocks that the sun went down. I didn't realize that I recorded quite a bit of dark. So with that said, this video will take quite a while to play, and then it's just going to cut off because it has no end. The other thing I'll say is that while the process worked, it worked slowly. It did not work that well on the rocks that did not have a large amount of quartz. So if it was just a little bit of quartz, or it was kind of mixed materials, they didn't work near as well. And it was difficult to get the heat hot enough over the entire rock, especially to the center, to make it truly shatter the way I wanted it to. The areas that did get that hot did it very well. So if I was going to do this again, I would either build a cupola style furnace using solid fuel, or I would actually use a ceramics kiln, put a steel pot in it, fill it full of quartz, and just turn it up to 1100 degrees and leave it there for an hour, and then pull it out and dump it in water. But either way, this is going to be a lot slower than I would want it to be. I just can't afford a jaw crusher, and I'm far too lazy to go out there with a rod and a dolly pot and beat it up. So with that said, I'm getting ready to move on to my next phase of the project, but enjoy the rest of the video. I don't know if you can hear it or not, but I'm getting a little popping. Kind of sounds like the rock is just kind of popping apart, little chips. Given that most of them are falling more or less straight down into that catch where I've got these river rocks to catch any fragments, I'm not too terribly worried about it. If something valuable ends up falling, I'll just sweep it up later. Checking the bottom side there, it's about 500 degrees. One thing I should mention, when you're dealing with just galena, not the quartz, the old timers used to take the galena and roast it. So this is lead sulfide. And what they would do by roasting it, basically same process I'm using here except for just galena, is that they would drive the sulfur off the lead and replace it with oxygen from the air. That created a lead oxide. And then in a later step of smelting, they would use charcoal or carbon to replace the oxygen, or to strip the oxygen, making CO2 and leaving the pure lead behind. It's kind of a two-step process. It does put a reasonable amount of sulfur off into the air when you do that, and I'd rather kind of avoid that. There's a second way involving iron that I intend to use more of. I will get a little bit of lead oxide out of this. It's just part of the process. I'll even have some already naturally, because these rocks came from a mine where they've been sitting out in the weather for about 100 years. So naturally the chemical reaction occurred, but it occurs much faster under heat. That shows to have gone back down in temperature a bit. I'm going to turn gas up. And I can't stress how much I have no idea what I'm doing. It's my first time. I'm heating a rock on an open flame. The thing could shatter and go everywhere. We'll find out when we find out. So don't try this at home, kids.